Yes. So I'm coming from Finland. Finland is rather cold country. If you say good morning in English or in German Guten Morgen or whatever languages, in Finland we just say morning, huomenta. And you can, it's not rude way to say things, but we want to be efficient in a way that if it's morning, it's morning. Not if it's bad morning or good morning, we don't care, unless it's morning. And so CSC is a non-profit organization or company owned by Minister of Culture and Education. So we are providing all the storage capacity and computing power for universities in Finland. We have facilities in Otaniemi. We have 250 people working there and 5 people working in Kajaani. And whenever possible, when our mother gives us money, we will buy things. And a couple of years ago, we had a procurement phase with our current HPC environment, including storage. And I have to say that I was really skeptical about DDN storage on that time. And Auke was still delivering the proposal that how to get all the things that we need in our site. So our storage challenge is, well, we are providing different kind of services and applications for our customers. We have these memory organizations like Finnish National Audiovisual Archive, National Archives, National Galleries that wants to store their data for longer term way. So for that we need something which doesn't consume that much power, so tape. And then we are in national and international and collaboration projects like UDAT, and those requires also storage, and we have to tackle the problem that normal customer might have in our site might have 10 different applications, and we need to face that. Well, you're filling terabytes and kilobytes of data at the same time, and you need tape archive and HPC fast archive and that kind of stuff. And I was mentioning about the Kajaani and Espoo. So Espoo is here, normally warm in a Finnish scale, and Kajaani is here. So the distance is bigger than normal would expect. And all our customers, well, universities in Finland, they are scattered around, like here in Oulu, there is a big site, Rovaniemi, Joensuu, Kuopio, Tampere, Turku, they are all around in Finland, and we are providing also the high-speed network between the sites. So the speed of the network is not that issue, so that's why we have done the computing environment on one place. It used to be on Espoo, but nowadays we've moved the HPC computing power to Kajaani. So we had this procurement a couple of years ago, and as a result, Auke was lucky enough to bring all the needed pieces to provide us an archival solution for these memory organizations that we are having different solutions, and HPC storage for Kajaani. So our archiving solution is based on DDN 10Ks. There is a SGI CXFS DMF environment for using this handling of tapes and disk cache. And then there is a SpecLogic Tfinity tape robot for the tape handling. And you normally expect that DDN provides those 10Ks and 12K disks storage, but they can provide a full set of like Tfinity tape robots in this kind of procurements that we used to have in Finland. So our archival solution it's rather small, but it has still DDN 10K. It's needed because the tape robot is sun connected. So 10K has the sun connectivity in a way that we are using it. And there is a different sections of it. There is a DMF area which take most of the capacity, and then there is also way of speeding up our existing backup softwares. There is 2 different backup applications running on our site, and we shared also the capacity from this 10K to those different backup softwares. We don't have any online spare disks on that machine. We have on-site spare disks, and well, you could expect that in Finland we have flights and we are coming rather close. We are in Europe, that it's not a problem to deliver stuff in Finland, but almost all the vendors has challenges to have the logistics in Europe. And when you go to Finland, you will expect that, well, you might have a spare part, but it's not for you. It's known, and that's why we have on-site spare disks. It's 10 years learning that we need something which is on-site. Our archiving robot is Tfinity with the 7 petabytes of capacity. There is expandability on both sides, so we can increase the cabinet size, and as we are getting more and more data, we can expand that sideways up to whatever we need. And currently we are using 3 different partitions. So we have our HPC archival platform, and then we have a longer term test bed for our one of our demanding customers, and then there is a service partition. But we expect that we can use that Tfinity on more than just with these 3 partitions, and that was one key point that we wanted Tfinity in our site, because now we can share one tape robot for the different customers. The minimum requirement is of course one tape drive for one customer, but we can split our capacity more efficient way than we used to have with our previous archive system. And well, we are expecting our LTO6 drive to Tfinity, but there is on the SpecLogic side there, multi-picker functionality is not that ready that they are willing to bring it our site. So that's why we are running just Jaguar tape drives currently on our tape robot. And the archival solution that we are running nowadays, it's well, DMF. There is a cache with a SFI 10K. There is the tape robot for storing the capacity, and our previous system had just one machine serving the customers, handling the metadata and SAN connectivity to tape and disk cache. And it was just so small that we couldn't increase the throughput of that system, even we tried many ways. So this time we decided that we need something that is scalable enough for our customer needs, and that's why we are nowadays running DMF, because we can share the load between the PDMs and metadata servers, and if needed, we can just add more NFS or CIFs or whatever servers to access the disks on 10K, and then the metadata is running on a normal Ethernet network, but it's also a redundant network. So I draw there just that SAN network is redundant, but our metadata network is also redundant, because we are providing different services with a one machine or one setup. I'm considering this as a one machine, even it's based on normal PC technology with more than 6 nodes. And previous speaker was talking about iRods. We have a NFS connectivity to our iRod services, so that's fast enough 10 gig connections between the iRods and our NFS nodes. And we decided to go in an old-fashioned way with the NFS to provide these customer endpoints, like the iRods was one, and then there's others for radio and TV archive and that kind of stuff. Because if they have something special that they want to put on a network, we can still give something which is known. And NFS it's not good, but you can live with that. So in Kajaani, it's not that far, 1,700 kilometers from here, and the distance in Finland is just around 500 kilometers. You know the speed of the light? I think that you do. That's one problem. We are getting latency issues transmitting data between our sites. So even that's the closest way to go from Espoo to Kajaani. We still need to go around different cities, and it's more than 600 to 800 kilometers on a cable way to go from Espoo to Kajaani. So we can't provide our HPC capacity in Espoo and then use our supercomputing power in Kajaani. And you know that energy is quite expensive, so we decided that since in Kajaani the average temperature is 2 Celsius, we don't need that much cooling power. This summer or this spring has been somehow strange, because our water in lakes in Kajaani is currently around 20 Celsius. And at the same time, in Germany, you're having here raining and floods and everything like that. And we are having, in Finnish, called Indian summer in the north of Finland. So I hope that our supercomputing power is not affecting there that much. But this picture is taken from our computer facility in Kajaani when they were setting up our Cray machine. So all the people that were putting stuff in there, they had winter cheer around, and it was really chilly. That's not because of the cooling.
Is this ice? There's two different.
This is ice. Yes, it's frozen. It's front of our hall.
And it's not inside.
It's not hot inside. Well, past 3 weeks we having some challenges with hot air, but not normally. So our data center is located on an old paper mill, or specifically on a old paper warehouse where they used to store the rolls before they are going to abroad. And they closed the paper mill factory, but there's enough power to use computing environments, since there's a own power plant, then there's a water power plant on the same area, and we have also cables coming from national grid in the same place. So we have 3 times a possibility to increase the capacity on that site. So we are not having problems with the power in Kajaani. That's good. So HPC machines in Kajaani, there's now 2. Well, I count 2 machines. The third one is on a prototype level, so we are not talking about that yet. So we have a Cray XC30, which was, I believe, the first install in Europe on this scale of machines, or this type of Cray machines, called SISU, which is, I don't know how do you translate that, but it resembles a Finnish way of acting or doing things. So sorry, I skipped the translation because it's not on my mind. And the picture on that machine is actual photo on that area. So we have a lot of Northern Lights activity in north of Finland. So that's the reason for this Cray layout or the graphics on it. Well, we have a like commodity HP Supercluster on that same place, which is called Taito, which is Taito skill is maybe the closest translation for the name. And they have different kind of applications running in those machines, so I don't know which is the best one for certain users. That's why we have 200 people to work with the customers. I'm just trying to deliver the storage for them. And well, this is overview for our Cray and HP machines, and there's our previous Cray Louhi and our previous HPC cluster Vuori, and you can see the scale that we got in 3 years up between those machines. If you need these slides, you can get them from Laura, I believe. So, and if you can ask them also from me, or you just take the Excel sheet from the newest list, top 500 list. I hope that at least our Cray is there still. So for storage in HPC in Kajaani, we got it's based on 12K DDN machines and we got in phases because our money is given to us in phases. So first phase was 1.2 petabyte, and phase 2 1.8 petabytes. There was slides earlier about the speeds. So these are the speeds that we are seeing constantly in our environment in Lustre. So our HPC guys are really happy about the speed that we are getting from these DDN boxes currently, because we have more than 700 different applications running on those machines. If you could tune the storage and the HPC machine properly with like 10 for 10 different applications, you could get maybe even more greater speeds. But we are really happy about the speed that we are getting right now. And well, there's not phase 3, but I expect that something like that will come, because normally when you buy first one and second one, and if they are working, okay, we'll do the thing. Discuss with managers at CSC. So I don't have a proper picture of Taito, so that's why it's just the InfiniBand connectivity graphs. So there's around 600 nodes that are getting FDR connectivities with a 28 nodes as a one link, and then there's 8 FDR links between the every leaf node to the core switches, and we are providing non-blocking capacity for Taito and also for Sisu. And with this Cray machine, we are having separated nodes for transmitting and getting the data from DDN 10K, 12K machines. And then there's also separate login nodes for the customers, and they can also see the same Lustre file systems, but they are not slowing down the Cray internal connectivity to the DDN boxes. So that's why there are separate connections between the customers and our InfiniBand network. And what else? So we are set up those phase 1 and phase 2 file or storage systems in a different file system. So there's a Lustre 1 and Lustre 2, and they are all visible in all the nodes in our system. So if we are having some issues with the one Lustre, we can still operate both machines on a at least on a 20 gigabytes per second speed. Do you have any questions about this solution that we are having here?
Is there something driving the 4x increase in compute capacity that you have coming next year?
Well,
is there science or something?
Our science customers, they are expecting the constant growth, and I hope that we are getting the money. When you have the money, just try to spend it as wise as you can. And when I started speaking, I was really skeptical about DDN boxes. So can they really deliver the speed that we are expecting that this generation machines can use? And by far, they've been working quite well. Of course, we are having these logistics things, which is known. Kajaani and Espoo, they are different sites, and if something is not that good, I really would like to get better logistic thing on a DDN delivery for the spare parts, but otherwise I've been really happy with these systems.
There's no specific code that requires the 4x speedup that you're planning for?
Excuse me, I didn't.
No specific code or any sort of scientific platform for the 4, when you go to 2.2 petaflops or so?
Yeah.
Is there anything you're planning for that you can run at that level of scale?
Yes, there are different applications. I don't remember all the names, but if you go to our booth on there, I can give all the application lists that we are running there.
I just want to know, how do you have applications where the user produce small files, and how
yes.
Deals with that?
Well, our customers, they tend to produce a lot of small files, and that's really annoying as a storage guy. I hate it because they could at least think first, but since they have 600 nodes to run, they think that, well, 1 kilobyte result is just fine. And despite that, we have managed to get decent speed in our system. The current bottleneck maybe is the metadata servers on Elastra. We are having a couple of metadata servers, and also for storage that is provided from DDN. So when the Lastra 2 point something will come, we are expecting to get faster speed for small files. But no, I can't say. But the speed that we are getting, the number is 20 gigabytes per second with the one phase and 28 with a second phase. There, it's mixed load already. So small files and big files. Anything else? If no, thank you. You can see me on our booth.